So you've got your GPU installed in your server, and you want to add the EGX stack, but you want to do it on top of a VM. Yeah, we can do that. Today's install is based on NVIDIA's EGX platform for edge computing with the EGX stack. We're going to put a slight twist on it today in that we're going to build it on top of a VM. So I've got as our base server Ubuntu 18.04.5 with a KVM Hypervisor on top of it. On that, we're going to build an Ubuntu 18.04.5 VM with Docker, Kubernetes, and NVIDIA GPU operator. For your physical setup, you're going to need a workstation. In this case, I'm using Windows 10, your server with a GPU installed, a router, and connection to the internet. Software we'll be using today will be Rufus for creating our ISO flash drive, PuTTY for SSHing into our server, and WinSCP for transferring files up to the server. We begin our install today with our server hardware and our initial Ubuntu 18.04.5 install completed. If you need to get to this point, go ahead and look at the first video in this series. It will give you a detailed walkthrough on how to create your flash drive and how to install Ubuntu for the first time on your server. Ideally, as we work through this video, you will have 3 windows open on your desktop. The first one being your browser with the page associated with this install. The second one being PuTTY, SSH'd into your server. And the third one being this video, which will show a split screen of my 2 windows, my browser and my PuTTY window, as I perform the commands. This should allow you to follow along step by step, observing what happens as I execute my commands, executing them on your server, looking for the same responses. Pause the video now, get your 3 screens set up, and let's get started. The left-hand side window is our SSH PuTTY connection to our server. The right-hand side is our web page that's associated with this install. I've been through the install stack. At the bottom of the summary, I mention the NVIDIA ngc.com sign-up page for the NGC catalog. It's not required for this install, but if you will be accessing the catalog, you might want to go and sign up for that. Configuring the BIOS and beginning the install. This is for the host that we're looking at right now. So before I installed Ubuntu, I went into the BIOS and I ensured 2 things were set. Number 1, advanced PCI settings. You want to look for above 4G decoding and make sure that's enabled. Number 2, ensure that your virtualization technology is enabled. You're not going to have a successful install if either one of those are not enabled, or if your BIOS doesn't support them. Verifying our server status. This is a series of commands I like to run after I've got a fresh install going. I've already been through these, so I don't need to do them, but I'll run past one just to show you the routine here. On the right-hand side, on our web page, I've got a series of clipboard icons. If you want to run a command during this process, you will click on the clipboard icon with your mouse, left click. You'll notice that the contents of the cell get highlighted in blue, and they also get copied to your clipboard. I can take that content and I can go over to my PuTTY window and I can right-click, paste it directly in, hit enter, and I'll execute that command. So the highlighting in blue is a good function because it sort of lets you know the last command that you ran. So this is a long process, there's many steps, and it will let you know what the last step you ran was. Configuring our network bridge. Let's take a look at the netplan directory and see if our config file's in there. And it is. Let's back up the original. Let's determine our network interface. And in this case, it is ENP9S0. You're going to want to remember that. It'll be different on yours. We're going to configure the bridge, and you would replace this with your network interface. I'm going to execute that now. Good, looks good. We're going to verify it. Wrote correctly. Now we're going to apply the NetPlan configuration. After executing NetPlan apply, our network interface is changed to VMBR0, and our IP address changes as well. This will obviously disconnect our SSH session. You need to go to your router and look under attached devices and determine your new IP address, or go to the physical server and take a look at your IP AD and figure out what your new IP address is. Once you've got that, go back into PuTTY SSH and reconnect to your server, which is what we're looking at now. Let's take a quick look at VMBR0. If you needed to hard set your IP address in your router, you can pick up your MAC address right here. And let's double check the status of VMBR0. Looks good. Let's start with our pre-install updates and file transfer and go headless with this server. First, I'm going to WinSCP the file up into the server. I've got my WinSCP set up, and I'm going to transfer my file over to my directory, the admin directory on the server. There it is. Now that we have our file moved, let's take a look at the directory and verify it's there, which it is. Let's create a new directory, media installs, and let's move that file over to that directory. Let's verify it's present. Great. Let's do an update. And we'll upgrade to our updates. Let's disable Cloud.init. We've got a split here. If your server has an integrated graphics card, go ahead and do a reboot. If you have a discrete graphics card added in addition to your GPU, we're going to want to shut down and remove that graphics card at this point. I'm going to shut down and remove my card now. We are back from our shutdown. Let's continue with GPU pass-through configuration. We need to make an adjustment to the grub file. And let's verify that tweak. If this were an AMD, we would change that to AMD IMMOU on. Let's regenerate grub. Let's take note of our vendor IDs. These are the numbers you're interested in. Let's include those IDs in our initramfs. And let's verify. Looks good. Let's load our VFIO PCI before our Nouveau drivers. And verify that. Looks good. All right, now we're going to assign our vendor ID device IDs to VFIO PCI. And verify those. They're there. Now we're going to assign VFIO PCI as the kernel driver. Verify that. Looks good. Update init RAM FS. And we give it a reboot. And we're back from our reboot. Let's verify our IMMOU is enabled. And it is. And let's verify our GPU is using the VFIO PCI. And it is. Great. And we'll continue with our KVM install. First, some dependent packages. Now we'll do a virtual host validation. Make sure we get a pass on all these. Enable vhost.net -net. Confirm that our kernel modules are loaded. We're going to enable vhostnet in modules. Only root and users in libvirt have permissions to KVMs, VMs, and VMM Therefore, we're going to verify and, if need be, add admin users to the libvirt group. First, we're going to verify the admin account is present. And you can see that my account is at the top of the list here. So it is present, sorry, right here. So I don't need to add it. If it wasn't present, I would add it with these commands here. And we're going to do a reboot. Back from our reboot, let's get started with our XRDP install. Straight off the bat, we're going to install XRDP. And let's do a status of XRDP. It's active and running. You're going to add XRDP to the SSL cert group. Done. Verify. And it is there. I'm going to restart XRDP. And we will enable it as well. There's an error when you log in via RDP that you will sometimes get. It's the authentication required to create managed color device error. If you create this file, you will not run into that error. And let's verify that file's there. Looks good. If you logged in and you already experienced that error, you'll need to clear the var crash directory with this command on the right here. Continuing with our host display manager install. This is going to be a minimal install. And let's start the GDM3 service. Let's check on the status. Up and running. And we're going to give it a reboot after that. We're back from our reboot. I'm logged in as admin, and we're going to continue with creating our virtual machine. Installing VM via command line is a pretty simple process. Installing Ubuntu over command line is a tedious process. So we are going to RDP into our server, and we are going to use Virtual Machine Manager to create our virtual machine. We're going to start by verifying our ISO file is in our media installs directory, which it is. And now we're going to RDP into the host. You're going to use a session xorg. Put in your admin username and password. Select activities. Click on the ellipses. And let's open up a virtual machine manager. With virtual machine open, we are going to click this icon to create a new virtual machine. We're going to select local install media. We're going to use an ISO image and we're going to browse for it. In this case, we are going to say browse local, other locations, computer, media, installs, and if I can pull it on the screen here, and you click the open button at the top. We're going to allow it to automatically detect the operating system. For memory, I've got quite a bit of memory on this server, and this is my only virtual machine on it, so I'm going to give it 32 gig. And I've also got about 12 CPUs. I'm going to give this VM 4 of them. For my disk size, I'm going to give it 80 gig. And I'm going to name this Ubuntu 18 VM. If you're following along, you want to use the same name. I do want to customize configuration before install. And under network selection, I'm going to select specify shared device name. And the bridge name we're going to use is the one we created before, which is VMBR0. Here we're going to add hardware, and it's PCI device. You'll scale down here. Yours may be slightly different depending on the GPU you're using. This is mine. And with that, we can begin our installation. I'm going to trim down this install to the highlights. It's about an 8-minute install, so I'm just going to select English, install Ubuntu server. I'm going to continue without updating. English is fine. We can make note of our new IP address if we wish. Don't need a proxy address. Mirror address is fine. We're going to use the entire disk, the 80 gig that we provided. And we can see how our disk is going to be used. And we will continue. We will install OpenSSH server. And we will not install any of these additional components. We are back from our reboot, and we are now going to edit our grub file. Your clipboard functions won't work here, so you're going to have to manually type these in. But first we're going to sudo nano etc default grub. And the line we want to edit is right here, the command line Linux default entry. The modifications you'll need to make are in the web page, and you're going to modify the line to match this one right here. Console tty s0 cgroup underscore enable equals memory, and swap account equals 1. Once you've made that addition, you're going to Control X, yes to confirm, and then enter to write. And now we'll use sudo grub make config in order to regenerate our grub file. Once this is done, we can check out our IP address again. And in this case, you can find, if you need to hard set your IP, you can find your MAC address here and the IP address that the VM is using. And we'll end out this section with another reboot. Our reboot is completed. I have closed the RDP session, and now I am SSH'd into not the virtual machine, but into the server, the host. I'm going to virtual console into the machine that we just created. I'll log in with admin account. We checked our details previously. Let's take a look at our drive space and see how it's been configured. That's what we expected. Let's check out allocated memory. $32 gig, great. And let's run an update. And an upgrade. Let's disable Cloud Init. We blacklist our Nouveau driver. Verify. It's been blacklisted. We're going to update init RAM FS. After init RAM FS, we are going to update our time zone. In this case, I'm going to direct set mine. You can use this other option if you want to use the interface to do that. We're going to do a quick reboot to verify the kernel driver we want is being used. We blacklisted Nouveau. Log back in as admin. And we'll do an LSPCI to determine which drivers we're using. And you'll notice that Nouveau has been replaced with VirtIO for our kernel driver, which is what we're after. All right, now we're going to do a shutdown and take our first snapshot. Our VM is shut down, and we're going to begin creating our first snapshot. We can skip this first step because we're already shut down. Let's go ahead and create a snapshot of the VM. Let's take a look at the VMs that we currently have and list the snapshots of them. So our first one is taken. We'll get to it later on. I've included a couple commands so you can come back to this section when you take future snapshots. But you can look at this same format in the same information in a tree format. Of course, there's only one there, so there's not much of a tree to show. I can take a look at details of the snapshot, taken in a running state or a shutdown state, and some other details about the original file. Great. These next two commands you need to be careful with. You need to be aware of what you're doing. Delete is pretty self-explanatory. If you want to delete the snapshot, it does just that, deletes it. Reverting to a previous snapshot will take all the work that you've done since that last snapshot, and it basically erases that, reverts you to the state that the machine was in at that snapshot. If you save a snapshot of your current configuration, you can revert to a different snapshot and then go revert again to the snapshot you just take. Let's continue with creating our XRDP install for our virtual machine. You'll notice that I'm on the host server right now, so I'm going to have to start my VM and console into it. Logged in as admin. I like a larger screen size, and we will go ahead with installing XRDP. Go ahead and clear our screen. And let's take a look at the status of our XRDP. Active and running. Looks good, it's listening. Let's make sure we add our XRDP to the SSL cert group. And we'll verify that. There it is. Let's restart it, and then we'll enable it. Okay. Again, we've got the authentication required to create manage color device. Error will show up when we log in with our via RDP. So let's go ahead and create this file to avoid that error. Verify it got created. Looks good. If you had received that error previously, we would have to clear this directory, which we don't. And we're going to shut this down for another snapshot. And you'll note that we are back on the host server, not the VM. So we will create our snapshot. And now we'll take a look at our tree. And there it is. Great. Let's begin with our display manager install for our virtual machine. First, we need to start the VM and console into it. Enlarge my screen, and we'll go straight into installing the file dependencies here. Now we'll start our GDM3 service. And get a status. Active and running. I like to install Brave browser. It's a little less bloated than some of the other browsers out there. Let's install the GPG key. Set up stable repository. And the repository auto updates because we've already installed the key. We used add app repository. And let's install the browser. After Brave finishes installing, we'll open Remote Desktop Connection and connect to our VM this time. Let's click on Activities and our ellipses, and we can verify we have Brave installed. We can open it up just to test. And we can skip the intro. Great, we're all set. We can close down Brave and close down our RDP connection, and we'll take another snapshot. Again, note we're on the server this time. We've shut down our VM. And let's take a look at our snapshot tree. Great. And we're ready to begin our Docker installation. I've already started the VM and consoled into it. I've logged in as the administrator and I've increased my screen size. Next, we're going to install some packages. We're going to import the GPG key. We're going to verify it. Ends in D88, good. We're going to set up stable repository. And because we're using adapt repository, it's going to auto update for us. And let's install Docker CE and CLI. Now we're going to set up the Docker daemon. Verify it. It's great. We're going to make a directory and set up the Docker service D. If we were going to create proxies or specific no proxies, we will put a file in that directory. At this point, we don't need to do that. And we're going to reload the daemon. And restart Docker. Make sure it's enabled at boot. And let's check the version. In this case, 19.3.13. Check status. Active and running, listening. And let's verify it's working. First we'll queue to exit this. Hello from Docker. Great. We're going to add Docker group, and it already exists. We're going to make sure that our user admin name is part of Docker, and we're just going to check the group right now, show that it is not, and I'm going to add it. You're going to replace this with your username. Let's double check that to see it's in there. And now it is. Let's refresh the group. And this time I'm going to run the same command except without sudo, just to see if my admin account will be able to run it. Same message, so we're good. And we will shut down and take another snapshot. And let's look at our tree. Great. And that's the end of our Docker install. Installing Kubernetes. I have started the virtual machine. I have Virtual Console into it. I've logged in as admin. I've expanded my window. Let's ensure our BR NetFilter module is loaded. Let's disable swap. Let's comment out our swap entries in FSTab. And verify that. Last entry here, commented out. Let's ensure our net bridge NF call IP tables is set to 1 in syscontrol config. Let's verify that. Let's ensure our K8's confirmation loads at boot. Let's import our GPG key. Load our repository, which auto updates. And let's install kubelet, kubeadm, and kubectl. And we want to prevent them from unintended updates to future versions. So let's put them on hold. And let's initialize kubeadm and assign it a CIDR. And that's the default CIDR for Flannel, which we're about to install. We passed our pre-flight checks and the control plane has initialized successfully. Let's give our admin user permissions on the Kubernetes cluster. And let's apply our pod network. In this case, we're going to install Flannel. Let's examine our current taints on the node. You can see it's not schedulable right now. The master is not schedulable. We're going to change that, and we're going to allow pods to be scheduled. To verify that. And now we're at taints none. Let's take a look at the version of kubectl 119. Let's take a look at kubeadm. Again, 119 and kubelet 119, all 193. Okay. We're going to enable tab completion for kubectl. There will be a delay when we kick this off. It's doing some things in the background. When it's all done, we will see a nice display of what's happening to our nodes, our newly created pods. So after a couple minutes delay, we are now looking at this screen. I'm going to give you the full version here. This is why I like to expand my screen out. And you can see that all of our pods are not only ready 1 out of 1, but also running. And we've had 0 restarts, so that's a good sign. All right, we're going to shut this down now, and we are going to take a snapshot. Now that we have Kubernetes installed, we need to take some effort to shut things down gracefully for our snapshots. So I've included the command in the web page. Here it is. It drains the node and then cordons it. And we'll take our snapshot. and review our snapshot tree. Installing Helm and NVIDIA GPU operator. Okay, I have started the VM. I've consoled in through it through the server. I've logged in as admin and I've widened my screen. First thing we need to do is uncordon the virtual machine. And we'll watch things as they come up. These are the columns we're watching. We want to make sure, even though this says running, we want to make sure we get 1 out of 1 on the left-hand side and running on the right. There we go, all set. All right, so we're going to pull the Helm installation script. Give it execute permissions. And execute it. Let's take a look at the version. 3.3.4, what we were expecting. We're going to be registering the NVIDIA repo, Helm repo. If you have an NGC account and you've generated a token, you'll want to use it here. If you haven't, it's all right. We can continue with the install and there won't be a difference. Let's register and update the GPU operator repository. Let's verify the GPU operator is present. And it is. Version 1.2. Let's again verify our master node is schedulable. No taints, looks good. Verify our GPU is present. We're going to verify that we have no NVIDIA drivers installed. We're going to verify that we are not using HWE. Good there. We install SOCAT. I'm going to verify my version. 1732. We're going to load the message handler and make it persistent. Let's verify that. Let's take a look at our chart values. All right. And we're going to install a GPU operator. There's really no indication of what's going on in the background in this, so just be patient. And that was maybe a 2-minute wait on my part. Okay, let's take a look at Helm LS and verify GPU operators installed, and it is deployed, 1.2. As we watch these, it's going to be about a 10-minute wait before they're completed. You'll notice that this list will grow. In other words, as soon as some of these start running, they will initiate new pods. So I'm going to give you the highlighted version. I'm going to cut some time out of this, but it's about a 10-minute run to get these all up and running. One left to go with our GPU operator, and there it is. Okay, full set of readies, 1 out of 1s. You notice there are 2 of these that are called validation pods, and they will show up as completed. 0 out of 1, but completed, so we don't need to worry about those. Great. We're looking at all the pods now, but let's just get a more direct look at the GPU ones. See, they're up and running. Give you details if we want. Everything's looking good. Let's add the TensorFlow notebook to test it out. And we can watch it. Again, this will probably take 3 to 4 minutes for the initial install. And we're up and running at 3 minutes 58 seconds. Let's take a look at the pod. We'll cancel out of this, Control C. You can see that we have an NVIDIA GPU assigned to it. We're going to take 2 pieces of information here and we're going to drop them into our browser after we RDP into the VM. So first off, this IP address. And second, this token right here. With that, we will RDP into our virtual machine. We'll hit Activities. Hit our ellipse. We'll go into Brave Browser. I'm going to drop in the IP address. And go to it. I'm going to copy our token and drop it in. Now that we're inside Notebook, let's select New, Python 3. And you can copy and paste these lines of code inside. And you can see number of GPUs available, 1. So where you take it from here is your choice. And that's it. I'm going to shut it down. I'm going to take my final snapshot, and we're done. And let's take a look at our tree. And that's a wrap. I've got a few more videos planned, EGX on bare metal, and what to do with GPU operator after you've got it installed. If you'd like to make a request, you can put it down in the comments section, and I'll see you next time. Thanks.